Hi, in this video, we will explore the concept about infinite limits. Let us look at the following example. F of x equal to 1 over x. To this function 1 over x here, then we know we have a vertical asymptote at x equal to 0. So in p-calculus, we learned that as x approaches 0 from the left-hand side, with y go to negative infinity, right? We have this. Okay. So let us wonder how we use limit to talk about the situations like this then. Okay. So the definition 1 tells us that here we let f be a function defined on both sides of a, except probably at a itself. Then limit x approaches a of f of x equal to infinity. Mean that the value of f of x can be made arbitrarily large by taking x sufficiently close to a, but not equal to a. Okay. So then let us look at this example right here. So in this case right here, we have a vertical asymptote at x equal to a. Then you will see that as x approach a from the left-hand side, the function is getting bigger and bigger to infinity. On the other hand, as x approach a from the right-hand side, the function output is getting bigger and bigger, again to infinity. So in this case, we will say that the limit x approach a of f of x equal to infinity. But you have to be careful about this. Even though it seems that we make it equal to infinity, however, in this case, the limit does not mean that the infinity has a number. Okay. Or does it mean that the limit exceeds? In this case, the limit does not exceed. Okay. Again, infinity is not a number. Okay, so therefore, limit does not exceed. However, this limit right here is actually kind of like describe the behavior of the function that when it's approached a from the left and from the right, the function output is get arbitrarily large, getting bigger and bigger to infinity. Okay? Yeah. Then now, what if in this situation right here, again, we have a vertical asymptote at x equal to a. Then you will see that as x approach a from the left and from the right, the output, okay, that we have is getting bigger in the negative side. Okay. So therefore, in this case, we will say that the limit x approach a of f of x is equal to negative x then. Okay. Again, limit does not exceed. Okay. But it describes the behavior of the function output of the function, right? When it's getting closer and closer to the vertical asymptotes from the left and from the right. Then now, the line x equal to a is called the vertical asymptote of the curve y equal to f of x if at least one of the following situation is true. Meaning, when we have the limit x approach a of f of x equal to infinity, equal to negative infinity, x approach a from the left equal to infinity or negative infinity, or x approach a from the right, infinity or negative infinity. So in this case, then we could look at the following example, right? In figure 3, x approach to a from the left, the output go to infinity. From the right, go to infinity. From the left, go to negative infinity, or from the right, go to negative infinity. All of these situations is telling me that we have a vertical asymptotes at x equal to a then. Then now, try to see if we could work on the following example 1 now, okay? Now again, right now, I have the functions, okay? Then to this function right here is actually, I would like to evaluate the limit, okay? Or the function, right? Okay. And also, we would like to use the infinity, negative infinity, or does not exceed as appropriate. Okay. So then one thing about this problem right here, some of the problem you may be able to know how to do it because we have this type of problem before. Okay. When we try to that means first learning limits, we have this type of problem already, right? And then right now, let's see how to actually deal with if we have a vertical asymptotes, okay? Okay, so then let us look at the following example now, okay? So A, then we have the limit x approach 4, okay? So in this case, what I would like to do is, I would like to look at this has x approach 4, okay? So in this case right here, you will see that the limit x approach 4 from the left then is equal to 4. From the right, my output again is equal to 4. So then based on this, my limit exceed, it is equal to 4. And also f of 4 is equal to 4. So you will see that this example right here, from A to 4, it just tell me that we have a continuity, right, at x equal to 4 then. Okay. And now, let us look at this. Now I have x approach 2. Then when I look at this problem right here, at x equal to 2, then we have a jump. Right away, I know that the limit does not exceed, right? Okay, then let's see. We have this x approach 2 from the right. So to this one from the right. Okay. Then you will see that here, the output is equal to 6. X approach 2 from the left. My output is opposed to 4. So from the left and the right, they are not the same number. It's telling me that the limit does not exceed m. Okay. And of course, in this case, f of 2, okay, is equal to -4 then. Okay. Then now let us look at the last group of this example now. Okay. We would like to look at as x approach -3 now. Okay. So -3. Oh, we have a vertical asymptotes. Okay. At x equal to -3. Okay. Then now x approach -3 from the left. So in this case right here, it's getting closer and closer to -3 from the left-hand side. Then what happened? The output that I have is equal to infinity. The output is getting bigger and bigger, right? As x approach -3 from the left, y go to infinity. Okay. Then to this one, x approach -3 from the right, then the output that I have is getting bigger in the negative side. Okay. Then I will have negative infinity then. Then now I have x approach -4. Okay. So approach -4. Okay. You will see that from the left, my output is 5. From the right, also I have it equal to 5. So therefore the limit exceed and the limit equal to 5. Okay. Then what is f of -4? Oh, we have a hole, right? So it will be does not exceed. Okay. Yeah. Now, let's see how do we evaluate the limit of the form that the limit x approach a of f of x over g of x, where the limit x approach a of f of x not equal to 0, and the limit x approach a of g of x equal to 0. Okay, so in this case, we have a situation that we have a number divided by 0. Okay. Now, remember this situation right here is different than what we did it in section 2.3. In section 2.3, we have a limit x approach a of f of x over g of x, then is actually equal to 0 over 0, right? We have this in indeterminate form. Okay, then again, remember we have 3 ways to solve the problem. One is we factor it out and then simplify. Second, we expand it out and then simplify. Or maybe we could work with the conjugate pair, right? Okay. And again, simplify it. So right now, if we have a number divided by 0, okay, then one thing that if you remember, if I have a number divided by 0, then in this case right here, we say that we have the number again is undefined because we don't know what it is, right? Then in this case, if we work with the limits, then how do we actually work it out? Okay. Now in this case, then you have to remember that the limit does not exceed because it's not a value, right? A numbers. So, however, the value of f of x over g of x become unbounded as x approach 0. What does this mean? It means that the number, okay, this limit right here is either go to negative infinity or infinity. Okay. Then in this case, the line x equal to a is a vertical asymptote. Okay. So again, for example, like if you have 1 over x, then in this case right here, as x equal to 0, the function is undefined, right? So we have a vertical asymptote at x equal to 0. Then this is the idea. Okay. Then now, how do we actually work it out this problem? I know that the answer that I have, okay, to the limit is either negative infinity or positive infinity. Okay. However, how do I know that is negative or positive infinity? Okay. Now let us look at the following pattern. Okay. So if I have 1 over 0.1, okay, then you will see that the answer that I have is 10. 1 over 0.01 is 100. 1 over 0.001 is 1,000. Okay. So then you will see that if I have 1 over the number that I have is getting closer and closer to 0, then what happened? The output that I have is getting bigger and bigger, okay, to the positive number then. On the other hand, if I have 1 over negative 0.1, then I have negative 10. 1 over negative 0.01, I have negative 100. 1 over negative 0.001, I have negative 1,000. So if the values, okay, is a negative number, if this number right here is a negative, then when I have 1 over the number is getting closer and closer to 0, then I will get to the negative number, and then the number is getting bigger and bigger then. Okay, so based on this concept, then let's see how can we work it out this problem now. So let's look at this example right here. We know that as x approach 1, then we will have, again, direct substitution, right? 1 plus 1 over 1 minus 1. So now I have 2 divided by 0, okay? Then I know that the answer to this limit either positive infinity or negative infinity. No other choices, okay? Then now let's see how do we know if it is positive or negative. Then I would like to know if, okay, when we evaluate, if it's give me the positive number or give me a negative number. Okay. Okay. Then how do we actually work it out this problem? Okay. Then this is how I think about this problem. So I have x approach 1 from the left. Okay. Then in this case, meaning the number that I have, okay, it will be about 0.9 and then 0.99 and then 0.999, right? You see, if I approach from this side right here, okay? Then if I work with this expression right here, I'm replace x with 0.9, okay? A number that is really close to 1 from the left side. Then I found out that is 0.9 plus 1 over 0.9 minus 1. The top, I have positive. The bottom, I have negative. Okay. Then it's turned out that this expression, it give me a negative result. So based on this, I know that the answer that I have is negative infinity then. Okay. And again, to this limit is actually tell me that I have a vertical asymptote at x equal to 1. Okay. Okay. Then now, let's try the next example, okay? So to this example, then, again, let's try the direct substitutions. X approach to -3, so I will have -3 plus 4 divided by, okay, -3 squared plus 5 times -3 plus 6. Okay. Then I will have 1 divided by 9 minus 15 plus 6. Okay. Again, I have 1 over 0. Okay. The result then is either positive infinity or negative infinity. Then let's see. Now the same situations, we could actually do this. Okay. We have this approach to -3, okay? From the right-hand side. Okay. Then now, I will try to work it out the problem. So in this case right here, I actually, okay, again, start with -2. That means in this case, maybe we could choose a number, -2.9, right? To plug it in, to work it out the problem, okay? But you will see that when I plug it in, it seems that I need to use my graphing utility to actually to work it out. But what if I do it this way? Okay. I find that this expression right here, quadratic, right? X squared plus 5x plus 6, I will be able to factor this to be x plus 3 and then x plus 2. Okay. Then now, this is actually easier for me to work it out the problem now. Okay, because again, I just want to know if it is positive or negative, right? Then now, let's try this. So again, we would like to replace x with 2.9. Negative 2.9, right? Then I have negative 2.9 plus 4 over negative 2.9 plus 3 multiplied to negative 2.9 plus 2, okay? Then the top, I have positive. And this one, I have it positive. And this one, I have this negative. Okay. So then in this case, I have a negative output. Okay. That means my answer will be negative infinity then. Okay, so now we are done with these lectures right here to introduce the infinite limit.